worn what Ledger's wearing right
Drew
now.
Teeter has been inside this before.
He has worn this?
Drew Teeter has been inside my coat before.
What about,
Okay.
what about his
Today we're going to teach you about money. You like money?
I love money.
Okay, we're going to teach you about money.
Give me that.
Yep. So suppose that Ledger inherits some money.
$1 billion.
That would be really.
Suppose he inherits $10,000.
Oh, I'd take it. I'd take it.
Billion.
Well, suppose you want to invest it and you want to, save it. You want to put in a certificate of deposit where every 6 months it earns an annual rate of 5.5% interest.
It's not bad.
How much money are you going to have after 10 years?
We'd have to do some math.
Would it be nice to know that answer?
It would.
And we have that right here today. Okay.
Ooh, compound
So,
interest.
compound interest. If you're going to invest, this is a formula that you can use. The difference between these two formulas is this. And this is important because this comes up on your test. This is if you compound it every so often. So suppose it compounds every year or every month or every twice a month, something like that. This would be the formula you would use. Suppose that's something that compounds continuously. For example, bacteria constantly compound. They don't stop, right? Like bacteria doesn't wait for the end of the day to all of a sudden grow again. It's always growing, right? So when things are growing in nature, then you use that formula, okay? So this is in nature where it's compounding continuously. This is really in money situations where it's at specific times where we're like hitting a button to compound, okay? So we'll start off with the first example here. A radioactive substance decays in such a way that the amount of mass remaining after T days is given by this function right here. M of T is measured in kilograms, or the mass is measured in kilograms. 1 kilogram is 2.2 pounds. But notice what we're given here for this equation. Does this look like our first equation or our second equation? Second, because it involves the letter E. E is what happens when it compounds continuously. Radioactive substances, they don't wait for the end of the week. It's like, okay, it's Sunday, the football game just happened, now I'll start decaying. They decay all of the time, okay? So the first question is find the initial mass, or the mass at time equals 0. So mass at time equals 0 means I'm just going to plug in 0 for T. And I have 23 times E to the negative 0.0043 times 0. And what is negative 0.0043 times 0?
0.
And what is anything to the 0 power?
1.
1. And what's 23 times 1?
1. Or 23.
23. So it starts out as 23 kilograms. That's the initial mass. Please don't get that wrong on the test. Drives me nuts. Okay. Everybody agree you can get that? Okay.
Yeah, I should.
Very good. How much of the mass remains after 21 days? So now we're going to type in 21. The mass after 21 days is equal to 23 times E to the negative 0.0043 times 21. What you reaching for there, Ben?
Calc.
Calc, let's go.
Let's go! Give me that.
There it is. There it is.
Give me that Python. Give me that.
NT.
23e to the negative 0.0043 times 21.
20. Clear. 23.
I've got 21.014.
Wait, question.
Yes.
It needs to be in parentheses?
So the exponent should be in parentheses.
Got it.
If you click second log of the second natural log, it already does.
Oh, thanks, Ben.
Thanks, Ben.
21.
What?
Is it kg?
Yep. 21.014 kilograms.
kg.
So it took 21 days for it to go from 23 down to 21. I want you to guess with the person next to you, make a guess. How many days will it take so that it's half of what it started? Okay? It looks like it dropped about 2 kilograms. Make a guess. Take 10 seconds, take a guess. Go.
So
guess.
half of 23 is 11 point, half 21 is 11 point, half of 23 is 11 point. I feel like,
So it takes 21 days to get down to 21.
so that
42
times 5.5, about
Okay.
150.
Kira, what's your guess? How many days?
Me and Keith have
Yeah,
educated
115.5
115.5.
days.
115.5? What's your guess?
You could,
115.5 days?
How did we do that?
Jackson, what's your guess?
What?
How many days?
come on, Dresh.
Hours.
Come on, Dresh.
Days.
Dresh,
Noah, you got a guess?
200.
200 days.
you're
Okay.
wrong.
Let's see who's
Okay.
closest.
Sorry.
I want to
guess I'm
solve this
wrong.
equation. Where did I get the 11.5 from?
Half of 23.
That's half of 23. It says after how many days is that half the initial mass? Notice I'm solving for t. T is up in the exponent. Until a few days ago, you didn't know how to do that, but now you know how to do it. What do I do to both sides? How do I solve? What do I do to both sides?
Do something with the T.
What has to move first here?
Oh, the E.
Before the e.
The exponent needs to get in the front, right?
Duh.
The T.
The T needs
Something with the exponent.
23.
I'm going to divide both sides by 23.
Oh,
Yeah, I forgot
so
about that.
nothing that we said.
I forgot about that.
And I get 0.5 is equal to e to the negative 0.0043t. Almost like we did this 2 days ago.
Maybe.
How do we get rid of the base of e?
Natural
Well, natural log both sides. I get the natural log of 0.5. Negative 0.693 is equal to negative 0.0043t. And now I solve by dividing both sides by negative 0.0043. And I get 161.197. So you said 115 days, you said 200 days, okay? Looks like right about in the middle of that.
Half.
So can everybody understand that if you're sitting in a chemistry class in college and you get that equation, can you understand why everybody sits there and say, I don't know what I'm doing? Okay, that's the type of stuff that your college courses are going to want you to be able to apply and remember. So, in order to get rid of 23, we divide. In order to get rid of e, we natural log both sides, but we have the solution right there. 161.197 days. Let's flip to a different scenario. Suppose that Kira inherits $1,500. Kira, you get $1,500 right now. What are you going to spend it on? What would you buy for $1,500? Clothes. Okay, you like clothes. Shoes? How many pair of shoes do you have? I dated a girl in high school. She had 60 pair of shoes in her closet.
Oh, Mr. Getz was dating a cool girl, I bet.
60?
60.
Everybody wanted Mr. Getz's girl.
It was.
Were they all like $60 a pop?
No, some were cheaper, but there were 60 pair.
Like
Yeah.
size 2 feet.
Yeah. Her parents wanted her to get rid of some.
No, I bet they were at least a 6.5.
Very
What
good.
if some of them were like $200?
All right, we're going to go to amount is equal to the principal times 1 plus the rate divided by the number of times raised to the nth power. Here, I'm investing money. It's going to be compounded every so often. And in this situation, it says that the rate is 8% a year, or 0.08. That's a good percent of return. If you could get 8%, you take that. Right now, certificates of deposit are getting about 5.5%, which is a really good amount still. Usually they're more around 3.
That way?
Part of the reason why they're higher right now is just because inflation was so ridiculous. Anybody know what inflation generally is on a yearly basis?
Probably like
1 or 2.
3%?
Oh, 3.
Yep. Whereas inflation, like over the past 4 years, has been more around like the 10% mark. It is dropping now. It's dropping again. It started about a year ago to drop, but it was bad worldwide. So It's compounded semi-annually. So that means twice a year it gets compounded, okay? And we're gonna compound it 5 years, 10 years, and 15 years. So here's where this information goes. The amount is equal to the principal, the initial investment that Kira has, $1,500 spent on clothes, times 1 plus the rate, which is 0.08, divided by n is the number of times it gets compounded each year, which is twice, raised to the number of times it gets compounded times the number of years that it is compounded. So everybody agree that t changes to 5 and to 10 and to 15? So instead of calculating this 3 times, I'm going to use my handy dandy calculator to make this nice and easy. Notice I have 1,500, and I multiply that by 1.04 raised to the 2t power. I took the 0.08 divided by 2 to get 0.04. I added it. Now I go to my calculator, and I go into my y equals, and I type in 1,500 times 1.04, and I'm going to raise that to parentheses 2x. And one thing that's awesome about our calculator is we have this table with which we can type in 5, 10, and 15. And it will produce for us these values. And that tells us the amount of money after those years. So Kira, if I can ask you, would you rather spend the $1,500 right now, or would you rather wait 5 years and then have $2,220? You'd like to wait. Would you like to wait 10 years? No? Wait in the 5? 15 years. So you'd be like 31 years old, 32 years old? Oh, it depends on how bad you want the clothes, I guess, right? That's a choice you have to make, is do you want to wait that amount of time? So if you guys could go ahead and help me out here, the amount after 5 years is equal to $2,200. $2,220 and how many cents? 40 cents.
Indeed.
The amount after 10 years is
I don't know how to get rid of
3,200.
86.70.
And the amount after 15 years is 4,000.
865.10.
So here's something that you don't necessarily think about at your age, but I think it's very important, okay? Let's change this scenario. Suppose that Zoe is getting a $5,000 gift. And suppose she gets 10% of interest on that gift. How much money is she getting? What's 10% of 5,000? 500. And then if she invested again another year, instead of it being compounded off of 5,000, it's compounded off of 5,500. What's 10% of 5,500? $550. You see how she's making more money each year, that the interest is also growing? So one of the most important things you can do, you guys all look for a job, and you're all like, I want to make money. There's different parts to your paycheck. Number one, part of your paycheck is what you take home. Another part of your paycheck is what gets put towards your health insurance. You know how much money it costs for a family like me to have health insurance?
Probably a pretty penny.
The district and my family together, combined total, it costs right around $26,000 a year. That's huge, isn't it? Then the other question is part of your paycheck, don't you want a retirement plan?
I do.
Or do you want to work forever?
You want a retirement plan.
So I put money every month into my retirement plan. And I don't get to really touch that money until I'm about 62 and a half years old. But one thing that's really cool is I can put up to 6% of my salary, and the district will match that contribution. They'll match up to 6%. So then instead of me putting 6% of my savings away, I'm putting 12% of my savings away. You can see that?
That's a good deal.
Yeah, and so there's incentives offered out there within companies for that. And so we've got a good option there. And your employers will have some options like that too. Might not be 6%, might be 4. 4 is more standard. But Albert Lee actually pays teachers a little bit less out of pocket and more towards retirement. It's kind of how they've structured it. So anyway, something you might want to know. Flip it over. We're going to skip 3, we're going to go to 4.
I'm on 4.
I want you to see if you can do the first question on your own. A man invests $2,000 in an account that is compounded annually at an interest rate of 5.5%. What's the amount of the investment after 4 years? I want you to do just that very first part.
Does that mean one time?
One time, yep. Jacob, you want to give me a shout out to what you got? Don't have it?
I got it.
What do you got, Keith?
2477.64.
Can anybody confirm that?
I'm probably wrong.
Somebody have something different?
No.
We're good? So mistakes that people make, different? Mistakes that people make is this 5.5%. It's 0.055. Sometimes people write it as 0.55. It's 0.055. Decimal point moves 2 places. Okay? And so I take that to the 4th power multiplied by 2,000. Look at the next question. It says, how long does it take for the investment to double? Okay? Kira says, I got $2,000. I don't want to spend it on clothes right now. I'm going to wait until it hits $4,000. Take a guess. How many years do you think it will take to reach $4,000? Take a guess. Talk to the person next to you. Take a guess. What do you think? Carter, what do you think?
16 years.
16 years. Let's see. I'm going to see when it doubles. So that's 4,000 is equal to 2,000 times 1.055 raised to the t power. Okay, so that t is the years that we're solving for. We're solving for that exponent. I divide both sides by 2,000, and I get 2 is equal to 1.055 raised to the t power. Now this looks ridiculous. How do we solve something like that? How do I get rid of the number 1.055? Do I divide by 1.055? Do I subtract 1.055? I take the log base 1.055 on both sides. And when I do that, I calculate the log of 2 divided by the log of 1.055. And I get 12.946. Did somebody say 13 years? Just about 13 years.
He's lying. Checks out. Checks out.
Checks out. Checks out. Checks out. Checks out.
Two more problems here. An investment of $800 was compounded quarterly. So quarterly would be how many times? 4 times over the course of 6 years. So 4 times a year for 6 years, so that'll be a total of 24 times is compounded. The initial investment resulted in this much. What was the interest rate? So we're trying to find the rate. So I have the amount is equal to the principal times 1 plus the rate divided by the number of times it's compounded each year, raised to the nt power. The amount says it's resulted in 1,245.83. What number do I put in for the principal?
800.
800. What number goes in for R?
We don't have that number.
That's what we're trying to solve. Divided by
4.
4 raised to the
4 times 6.
4 times 6. So 4 times a year, 6 years. So as we said, 24 times it gets compounded. There's our equation. Haven't solved one like this before.
We have not.
What do we want to do to both sides?
Divide by 800.
Divide by 800 is correct.
How did you know that?
I'm learning.
1,245.83. And I'm going to divide by 800. 1.557 is equal to the quantity 1 plus r over 4 raised to the 24th power. What moves next? The 1, the 4, or the 24?
24.
24, how do I get rid of that exponent of 24?
No, you do the square root of 24, or however you want to say that.
So I want to be clear, okay? John brought up a very good point. This is what people do sometimes, okay? They move the 24 in front. Remember that if you have the log of, say, 5 to the 6th, I can move the 6 in front because it's a logarithm. Do you have a logarithm right now? You don't. So you can't move it around if there's not a logarithm. So Keaton is correct. Just like if this, suppose that it said 24, suppose it was 2, you would then square root both sides. So you're going to take the 24th root of both sides. That's not something you've ever done before. I get 1 plus r over 4 on the right-hand side. How do we compute the 24th root of 1.557? The way I like to put that in my calculator, I take 1.557 and I raise it to the parentheses 1 divided by 24th power. That's what it means to have the 24th root. And I get 1.0186. Now to finish this off, we're going to subtract 1 and multiply by 4. And I get 0.0744. Or 7.44% is my rate.
Sweet.
You know, one time I walked in the, I shouldn't say this with the video on. I'll say it afterwards. Shouldn't speak poorly about people with that on. So, any question?
No.
Okay, last one. Rabbits.
Oh, gosh.
Rabbits. They multiply, don't they?
Really?
That's like all they do, right? They eat, they sleep, they multiply, and they poop. Like that. That's basically it.
That's it.
And so we can see that you have a logistical model here. That's what this type of equation is. It's got E in it because rabbits populate continuously. They don't ever stop. It's what they do, okay? It says that P is measured in thousands. That's going to be important in the problem. It's the number of rabbits, and T is the number of years that the population was tracked. Find the population after 10 years, and find how many years it takes for the population to reach 8,000. Anybody like a little confused by the problem?
Yes.
I would like to get a bearing for the problem by finding out how many rabbits are there at the beginning. Like, are there 0? Better be more than 0, because if you have 0 rabbits, they can't like reproduce, right? So let's figure out how many rabbits there are at the initial time. I'm going to plug 0 into this, and I get 30 divided by 1 plus 5e What's negative 0.3 times 0?
0.
0. So that will tell me how many rabbits there are at the beginning. E to the 0 is
1.
times 5
5.
plus 1.
6.
30 divided by 6?
5.
5. So we start with 5 rabbits.
That ain't bad.
We don't start with 5.
What?
I tried to hint this to you earlier.
5,000.
It's measured in thousands, starts with 5,000 rabbits. Okay,
That's a
great.
lot.
I start with 5,000. So now let's try to find the population after 10 years, it says. So all we're going to do is we're going to plug in 10 for t, and I have 30 divided by 1 plus 5e, and negative 0.3 times 10 is
Negative 3.
negative 3. So I got to type that into my calculator.
30 divided by
Parentheses, because we have multiple things in our calculator.
1 plus 5. Second natural log.
And I get 24.020. So we have 24 rabbits,
No. 24,000.
24,020 rabbits.
That's so much rabbits.
So let's be smart about it, because Mr. Gantz gives you a little bit of time on test so you can kind of check those answers and whatnot. It says right here, how long will it take for the population to reach 8,000? So if the population could reach 8,000, then my answer should be somewhere between
Yes.
0 and 10, right? Okay, so we're going to find that time.
3.
What number do I plug in for P?
8,000.
Not 8,000, but
8.
8. 8 equals the 30 over 1 plus 5e to the negative 0.3t. I can't state enough that you guys are graduating from college algebra, which means that any equation you see, you should be able to solve. That's the expectation moving forward. I had a problem just like this on your assignment. Anybody remember how they solved this?
Would you multiply 1 plus 5e to raise to the negative 0.3t?
You could do that, or Kira, you could. Right over 1, cross multiply. That's how I love to handle these fraction situations. I get 30 is equal to 8 plus 40 e to the negative 0.3t. Now the equation becomes simple. I subtract my 8, I get 22 is equal to 40 e to the negative 0.3t. I divide by 40, and 22 divided by 40 is, I happen to know that, that's 0.55. Now what?
Natural log.
Natural log, thank you, Big John. Natural log 0.55. I think that I not have that memorized. Is it negative 0.597? I remember from the other class. Equals negative 0.3t. And finally, I divide by negative 3. Or negative 0.3, excuse me. And I get 1.99 years. My answer was supposed to be between what?
0 and 10.
0 and 10, and it is. So that gives me a pretty good indication that my answer is reasonable. Please take out your homework.